So in this video today, what I'm going to do is I'm going to show how you can use an image to pass values into a VFX graph. And why you want values specifically in a VFX graph, I'll show in a minute some examples, but I was working on a VFX effect and I needed to compare a specific set of values to do some of my effect. And I really had no way of doing that. And in trying to figure out how to do that, I discovered that you can use it using the sample image map. You may have seen that when setting some properties. You could set properties from map. In this case, I'm going to use the values that are coming out of my image specifically and run some logic on them. And I'll show an example of that in a little bit. But first of all, I'm going to show how to create your bitmap such that you can encapsulate the actual number of values that you want to use. And in the case of reading a bitmap, essentially the colors are going to go from 0 to 255. 255 is going to be 1 and 0 is going to be 0, and all the values in between are going to be some fractions of that. And going from 0 to 1, you can always make the actual values whatever you want by multiplying it by some value. But essentially your color values are going to have to be something between 0 and 255. And so what I've done is I've gone into GIMP. I created a image 10 pixels wide because I'm going to encapsulate 10 values. And what I'm doing is in this case, I'm just going to make a color ramp essentially. And so I'm going in here and each one of these values is going to be some percentage of 255. In fact, each one's going to go up by 25, ending in 250, which is pretty close to 255. And I don't want to get into fractions. So my first one is 25. The second one is 50, 75, 100. So I'm just going in here and I'm changing my color values. I'm using the brightness here because that's the easiest thing to do, so I don't have to do it 3 times. I can make this 125, go on to the next one, and so on to fill out my total values. All right, so now I have my 10 values going from 25 to 255, so that's going to represent my values that I'm going to feed in. It's a good idea and really works best if you scale this up to some value wider than just 1 pixel each, because what we're going to do is we're going to be using a UV to index into this bitmap. And as 1 pixel each, technically it should work, but I found that because of round off values, and I don't know what happens internally in Unity, but if it's exactly 1 pixel wide for each color, it just doesn't, it isn't consistent. So I found that scaling it up to a bigger bitmap actually works best. So we'll do that. All right, so now we're going to scale this up. And what I'm going to do is I'm going to make 3 pixels wide of each one of these items. So we can go into image, scale, don't want these connected, make this 30 by 1, and we want no interpolation because we don't want it to mess with our colors. We just want it to duplicate each pixel 3 times. So if we say scale, we have 3 pixels of the first color, 3 of the second, and so on to be 30 pixels wide. So we can save this. We're going to export it over to our images where we're going to utilize it into our Unity project. So let's export it. All right. So now we have our image and we'll go over to Unity. So there's a couple things we need to do in Unity. So I've selected our 32 by 1 image that we just saved. So what I'm going to do is I'm going to set some things, turn off this sRGB. We're going to the format, we're going to make RGBA float. We basically don't want it to mess with any of the color values when it brings it in. We're not going to do alpha as transparency. Just select none and then apply that to our image. So essentially what we do is we have our 32 by 1, and now what we're going to do is we're going to use this image to pull the values that we set back out and utilize them into just a sample VFX graph that I've made. So let's take a look at that. All right, so what I have here is just a pretty standard default, just made a default VFX graph. You can see it's nothing special. Got a rate of 2 particles per second. What I've done is I have set the lifetime to 10. Just a basic velocity just to make a straight line of particles of a fixed size. And we can see they're coming out all at a 0.5 size, nothing special. But I'm using this as just a demonstration. It's kind of a basic demonstration, and you wouldn't really use this in real life, but it will show an example of what you can do and how to get the values out of our bitmap. So what I have here is I've created a texture 2D node and I've assigned it to our 32 by 1. And remember, there's 10, basically we've encapsulated 10 items. That's 30 wide. Actually, I named it 32. It's actually 30 pixels wide by 1 pixel high. What I'm going to do is I'm going to use this sample texture 2D node. And what it does is it takes in a UV. And if you've ever seen my other videos on using UV node inside shaders, we know that UVs go from 0 to 1. So essentially the X value is going to go from 0, which is the left-hand side of the bitmap, to 1, which is the right side of the bitmap. And the Y is the top. 0 for Y is the top, and 1 for the Y is the bottom. And so what I've done is what I'm going to do is I'm going to just make the Y 0.1 to go somewhat into the bitmap from the top. And what I'm going to do is one example that I've used is I've just put in a series of nodes here to select the X value. So essentially, as it goes across the bitmap, I want it to go from 0 to 1 and feed into that X value. And what I'm doing is I'm using the particle ID, which the first particle out is going to be 0, and it's going to count up. The next particle ID is going to be 1, 2, 3, and so on. The next thing I'm going to do is use the modulo. So what modulo does is essentially divides the number that's fed into it by the number, in this case 10, and it's going to give us the remainder. So 0 divided by 10 is, the remainder is of course 0. 1, the remainder is going to be 1. 2, the remainder is going to be 2, and so on, all the way up until you hit 9. And then when you hit 10, the remainder is going to be 0 again. 11, it's going to be 1. So essentially what this does is it lets us wrap and have numbers go basically from 0 to 9 continually on forever as the particles come out. What I'm going to do is I'm going to add 1 to it because I don't want to start at 0, because this is going to be used for the X value in the UV. I want to start it at 1 and I want to go to 10. Then what I'm going to do is I'm going to take that. So in this case, it's going to count numbers from 1 to 10. and I'm going to divide it by 10. So now it's going from 0.1 to 1. Then what I'm going to do is I'm going to subtract, add a negative 0.05, because at 10 it's all the way at the very end of the bitmap. And so I'm going to go back a little bit because I want it right in the middle of that last pixel. So essentially my UV is marching across the bitmap as my index or particle ID count keeps counting up to 1. Then what I'm going to do is I'm going to feed that into the X value, because my bitmap is only one set of pixels high. And so I'm going to feed that into the X. Again, the Y is fixed. And what's going to come out of here is a value, is a color value. And really the XYZ really represents RGB in this case. And so remember my RGBs are all equal, and the initial 25 is going to be equal to 0.1, the 50 is going to be equal to 0.2, and so on all the way up to 1. So now if I feed this in, any one of these will do, if I feed this into the size, then basically what it's going to do is it's going to set the size from the indexes or from the values that are coming out of my bitmap. So now if I come over here and I grab the X, I feed it into the size, zoom in a little bit, what we see is the values that are coming out are being used for the size. And it's just a way of kind of seeing what those values are to check to make sure we know what they are, because it's easy to see the visible size difference. And you can see it's starting out at 0.1 and going all the way up to 1 and then starting over again. So what we got is exactly what we wanted, is that we can read the values and we can use the values in our bitmap to essentially be utilized in a VFX graph. In this case, there's no reason to do that. In fact, you can do this set size from map and it will actually do the exact same thing. But in my case, I want to use these values. I want to do some arithmetic on them, do some comparisons on them, and I want to drive some unique features in my VFX graph from those values. I do not want to feed them directly into one of these attribute properties. So the example I just showed works great for a one tall bitmap. If you do have a bitmap with multiple rows that you want to use to encapsulate, maybe you want to make a 10 by 10 instead of making a really long bitmap, there is another module that I found online. In fact, I learned about this, tracked down, Googling around some information about extracting items from maps. And they use this point cache from UV. I'll show that in a second. So essentially, it's a bunch of nodes here. And instead of going through all those in detail, and I didn't make this, I actually, there's a store in GitHub that I downloaded that was part of this other video that I found, and I will post that link to that GitHub and you can download this yourself. But essentially what this is doing is you pass in a width and a height of your cache, and in this case mine would be 10 by 1. And what it's going to do is it's going to basically does the same thing I did with the modulo, but it's going to feed in the Y value and it's going to come out with a UV. The UV is basically the X and the Y. So then it will go across the first row and then go down to the second row and so on and so on. And I utilize this here. You can see this point cache to UV. And that pretty much works the same way. You can see that when I hook that up, I get really the same result as mine because it's just It's just a 1 pixel high. So this shows kind of how you can get those values out and a real simple example of using those. I'll show you something kind of cool that you can do with this with a bigger, more complicated bitmap, just to kind of show you maybe how you can incorporate something like this into a different VFX graph. All right, so for this example, what I'm doing is I've created just another VFX graph. Again, nothing special. What I'm doing is I'm doing periodic bursts, 256 particles per burst with a delay of 0.09 seconds between bursts. And I'm going to position those on a sequential line of 256 count. So each burst is going to do one line basically of pixels, 256 across, and every 0.09 seconds it's going to put out another burst and sets a lifetime of just 10, so it's a fixed height. And what I'm doing is I'm creating a random number for a custom attribute I call brightness. So what I'm going to do is I'm going to modify the brightness of each one of these pixels over time. So what I'm doing is I'm setting the color, and I'm just going to set basically the blue color. That's why you see the blue over here. And I'm going to use the VFX time. I'm going to get my float, and I'm going to add that. So the number that's going to feed into a sine wave will be offset by a random number. So essentially all my pixels are going to get brighter and dimmer based on a sine wave, and some of them are going to be offset by some random number between 0 and 3. And so if we zoom this in a little bit, what we see is and I don't know how good it comes through on the video, but basically there's pulsating colors or brightnesses on and off across this set of pixels. So that's the basis of our effect. And what we're going to want to do is I want to add an image, basically the imprint of an image onto these colors. And so I can use the values coming out of a map in order to do that. So what I have down here, let's make this a little bit bigger, is just like I showed before. This time I'm using this point cast UV that operates on our 2D bitmap to get our values out of it. And what I'm going to do is I've made a bitmap that's 256 pixels high and 256 pixels wide. It's best for compression to use numbers that are powers of 2. Unity likes that for compressing bitmaps, and since it doesn't really matter the size of the bitmap, I just made it 256. And if we go over here, I'll show you what the bitmap looks like. Where'd he go? It's basically a big M. There we go. So you can see basically it's a white M on a black background. You can see it's 256 by 256. I brought it in just like our other bitmap. So what I'm going to do is, let's make this bigger again, is I'm using our point cache, I'm using our texture 2D as that M image, feed into the texture, and then I am, instead of taking the UV exactly, I am going to take the X value and I'm going to negate the Y value. And you'll see why in a minute, because otherwise if I didn't negate this, our image would be upside down. And then I'm going to multiply, take that value. So that's going to basically get a value between 0 and 1. And I'm going to multiply it by 3 to make it a little bit brighter. So now it's going to be a value between 0 and 3. And I'm going to add it to our colors. And so it's going to make a brighter image wherever this is brighter. So when this is pure white, it's going to add 3 to our brightness. So if we hook that up, make this a little bit bigger, zoom back a little bit. What we can do is we can see our image, our M, and it's kind of stretched out, that is impressed upon all the brightness of the pixels. So if you had an effect that was made up of a bunch of pixels, you could actually add in kind of a ghost of an image onto your effect. And it could be a swirling effect, it could be a spiral effect. In this case, it obviously works best just as a straight linear effect. And if I didn't want it so stretched out, obviously I could squash our image to make that better. If I came into here and instead of, if I made this smaller, like 0.05, it's going to put out more, and it's going to be, you can see now it's not as compressed. Make it 0.03 and it's even going to be less compressed. Go to the game view. So you can see that if I didn't want it so bright, what I can do is I can come into here. If I multiply this by 2, it's not going to be quite as bright on the value. So I can play around with those numbers, but you can see in this way I can read those values as a map value and utilize them in effects by manipulating the numbers and feeding them into, in this case, the color and brightness of it. So it's really handy. It's kind of a hassle making the bitmap, but it is a way of feeding basically an array of integers into an effect. And I'm going to be utilizing this in an effect that I'm working on, this lightning effect, which is why I wanted to figure this out. So I hope this helps. I had fun figuring out how maps work, and it's just, again, one more tool in the toolbox for utilizing in your VFX graphs. So stay tuned for my next video and keep on watching.